We're in Rosen, Discrete Mathematics and Its Applications, section 1.7, your introduction to proofs. We'll take this in short videos to cover several different proof types. What is a proof? We've been talking about arguments, so a proof is a valid argument that establishes the truth of a statement. So we're going to make a statement, and then we want to prove that that statement is true. And like using rules of inference and logical equivalences, we will be including all steps in our proofs in this class. However, be advised that when you're reading mathematical literature, you will find that shortcuts are often taken when exhibiting proofs. So they might skip a rule of inference. They'll make something easy to hear, but maybe not very crisp in terms of its logic. And one of the things you can do whenever you encounter a proof in your readings is to make sure you understand it, make sure you can repeat it. That will improve your understanding of the concept and will keep you practiced in writing proofs and reading proofs. Why do we care about proofs? Well, besides the fact that we want to prove the mathematical theorems that we will use in this class and in others, they have some specific applications in computer science. In particular, we will see in another course that you can use proof techniques to show that a computer program is correct, that it always produces the correct output given a domain of inputs. And you can use them, we've already seen this, you can use proof techniques, truth tables, to show that system specifications are consistent. All right, so let's start with some definitions. A theorem, I've already mentioned a theorem, but what is a theorem? Well, a theorem is a statement, usually a mathematical statement, that can be shown to be true. And the way that we show that things are true is by using definitions, other theorems that we've already accepted or proven, axioms, which are starting points in mathematics knowledge, very basic things that we assume to be true about the world of mathematics. And you can see these in the appendix of your textbook. And then the rules of inference, like we discussed in the last section. A theorem is usually called a theorem, but it has some amount of importance. But there are other types of theorems that we prove. One is called a lemma. It's called a helping theorem. Usually a lemma is something that you prove in order to prove a larger theorem. It's a smaller theorem, a helper theorem. And then another type of theorem, which is also usually lesser, is a corollary. It follows immediately or directly from a recently proven theorem. But they're all theorems of a type that have to be proven if you want to show that they're true. And sometimes these less important theorems are called propositions. A conjecture, on the other hand, is a statement that we're proposing might be true, but we haven't found a proof for it. If it is ever proven to be true, it becomes a theorem. And if it's proven to be false, then it was a failed conjecture. Okay, often theorems are usually important because they are true for many aspects of mathematics, all elements in a domain, for instance. And because of that, there's often a universal quantifier implied in the theorem, even if it's not stated. So here we say x and y, when x is greater than y, when x and y are positive real numbers, then x squared is greater than y squared. Well, what this means is for all positive real numbers, there's that embedded or implied quantifier. So many theorems have implied quantifiers we have to keep in mind. And because of that, our theorems will often have the form of for every x, and then very frequently it will have p of x implies q of x. So when that is the case, we're often faced with just assuming that C is some arbitrary number, and we want to show that P of C implies Q of C, and then what that suggests is that many theorems that we will prove will look like P implies Q. And we've already done some proving of things that look like that using rules of inference. All right, so that's the lay of the land for theorems. In the next videos, we'll talk about how we prove theorems of the type P implies Q.